Okay, so let's try to code this up. So we'll follow the same example 13517. Okay, so first we'll declare a dp list. Okay, one star length of nums. Okay, and then we'll iterate. So for I in range length of the nums. Okay, over here so this is outer loop 13517, and there is another inner loop which is running till j. So for j in range I. Okay, now over here, so this is, let's say this is I and this is j. Okay, so if nums of I greater than nums of j. Okay, so in this case what we will do, we'll increment the count. Okay, so let's say dp of I is equal to dp of j plus 1. Okay, now over here, okay, so let's say 13517. Okay, so over here, let's say over here 17, so this is j, and this is, let's say this is I. Okay, so this is j and this is I. Over here what we will do, like we'll get I will get as 2. Okay, because j was 1 and then j was 1. Okay, and then we got 7. Okay, so 1 7, it is 2. Okay, but it's not the correct answer, right? Because if we consider till this, okay, so this up to this, so if it is j and this is I. Okay, so up to this we got as 3. Okay, and this is 2. Okay, dp of I we got 2, but up to this we got as 3. Okay, so now what we'll do, like if you get the max, okay, if you get the max, so this is the max. Okay, and this is, we got till this we got 3. Okay, so if we get the max, then we'll get the actual answer. Okay, so basically 3 plus, so up to this it will be 3, and then one more you are adding, like 7 you are adding, so it will be count, the length will be 4, right? So dp of I comma dp of j plus 1, if we do, then we will get the correct answer. And finally this dp list or array stores the length of the longest increasing sequence till the index size. So for example, if it is index 1, so it is storing the length of the longest lis till index 1, right? So in that case we can simply do return max of dp. Okay, it's passing. Okay, so if we submit this, passing as well. Okay, now what will be the time complexity for this? So time complexity would be O of n square. Okay, because you are running 2 loops over here. Space complexity would be, we are having a list of and 1D array or list. Okay, which is length of the num, so it is O of n, you can say. Okay, now let's optimize this using binary search as we discussed. So first I'll declare all of the, delete all of this. So first we will have a subs list, and we can initialize with the very first element of the nums array. Okay, then we will iterate a loop. So for num in nums, okay, if num is greater than the last element in the subs array, okay, or list, then we can do some, what we can do. So 1 3 5, so if 1 we have stored and 3 is greater than 1, so in that case we can simply append. So subs dot append num. Okay, else what we will do, we will find the smallest element index in the subs array which is just greater than equal to num, and then you replace it. So in Python we can use the bisect left, but in other language we can use the lower, we can implement the lower bound using binary search. Okay, so over here we can say k is equal to bisect left subs and k. Okay, so we got the first index which is just first the smallest element index, which is just greater than or equal to num. Okay, so this will be num. Okay, and then what we'll do, we'll replace it. So subs of k is equal to num, and finally this subs array will be having the lis. Okay, so then finally what we'll do, return length of subs list or array. So if we get the length, okay, it's passing. It's passing as well, 100%. Awesome. Okay, so what will be the time complexity for this? So time complexity, so this will be O of n, and then we are using binary search, so it will be log n. So total time complexity becomes O of n log n, and space complexity becomes, where in worst case it can store all the elements, so in this case, so it will be O of n only. Okay,